Hello, everyone. Let's read through the following question we have today. How can an engineer assess if it is valid assumption to consider a flow over a smooth, streamlined aerofoil as incompressible and inviscid? Once again, how can an aerospace engineer assess if it is valid assumption to consider a flow over a smooth, streamlined aerofoil as incompressible and inviscid? Don't let us forget that assessing the validity of assuming incompressible and inviscid flow over a smooth streamlined aerofoil always involve considering several factors or comparing them to the characteristic of the flow and the specific condition under which the aerofoil operates. Now here are the following valid assumptions on how engineer can assess the validity of the incompressibility and the inviscid flow over a smooth streamlined aerofoil. First of all, the Mach number. Mach number, which represents the ratio of the flow velocity to the speed of sound, is a critical factor. Incompressible flow assumptions are generally valid at low Mach number, that is, the Mach number less than 0.3, where the density variation due to compressibility effects are negligible. Aerospace engineer should always calculate the Mach number from the flow and determine if it falls under the incompressibility range. Also, Reynolds number, which relate to inertial force to the viscous force in the fluid, is very crucial and important in assessing the viscous effect of the streamlined aerofoil. Low Reynolds number, which is less than 10 raised to the power 5, might indicate laminar flow where viscous effect can dominate. In such cases, inviscid assumption might not be accurate. Engineer should always calculate the Reynolds number and compare it to a typical range of viscous effect. 3. Boundary layer thickness. Engineer should always assess the thickness of the boundary layer along the aerofoil surface. And in so doing, if the boundary layer is relatively thick, the viscous effects are likely to be significant, and the inviscid assumption might not hold in this case. And if the boundary layer is thin and not thick, then inviscid and incompressibility might be valid. Now let's table out all these valid assumptions for this our particular question. Firstly and foremost, from what we agreed upon, the Mach number, number 1, Mach number, that is MA, must be less than 0.3. That's the first assumption. 2, the Reynolds number. RE must be less than 10 to 5. Or Reynolds number greater than 1. Three, boundary layer. Must be thin. For inviscid assumption to be valid. 4. Viscous effect must be negligible. Five, shockwave form or formation must be negligible. Thank you for staying tuned.